to work on some problems from this first lecture. Since it's been a little while, it doesn't feel like a great idea to move on until you've had a chance to work on some of this stuff. And I think it'd probably be more productive for you to work on this stuff than just watch me do more examples. So that's my plan for today. We'll do this example to kind of finish this up and kind of review a little bit of what I think was the most difficult topic from the last lecture. And then we'll give you some time in class to work on the homework from the last lecture. And very likely there'll be situations where you run into that you want to ask questions about and gives you an opportunity to do that in real time and blah, 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 and less homework and all that. What do you guys say? I'm excited too. So, last time we've been talking about these radical functions. And in a situation like this where we have different radicals inside the same problem, we have to convert those radicals into rational exponents. So we started by doing a prime factorization for all the coefficients, right? Everybody's okay with that? I think we'd just done that, and then I ran out of time. What I'm going to do now is I'm going to convert each of these into fractional exponents now. So the third root, or the cube root, becomes a 1/3 exponent. A 7th root becomes a 1/7 exponent. And a square root becomes a 1/2 exponent. Everybody okay with that? Alrighty. So now I'm going to use my properties of exponents. So I'm going to use the power of a product and power of a power exponents. So I'm going to have 2 to the 1/3, 5 to 1/3, x to 1/3, 2 to the 5/7, because an exponent of an exponent multiplies, 3 to the 1/7, 5 to the 5/7, and then my denominator is just 2 to the 1st, 3 to the 1st, 5 to the 1st, x to the 5th. Oh, how did that turn in from an x to a 5? I don't know. Mackenzie was probably just getting ready to ask me that question. You didn't notice that you hadn't gotten that far yet? You would have, though, when you got there. You tend to catch all my stupid mistakes like that. But you ask so politely and nicely like you don't understand how I got that when it's like very clear that I just did something dumb. I appreciate that. Are we all okay with how I got into this space, though, or this place? Is that all okay? All right. So let's go ahead and combine some like terms. Now, in this problem, at least initially, I'm not going to worry about the denominator, because I noticed that all my exponents in the denominator are whole numbers. You guys see that? So I'm not going to worry about any of the denominators right this second. I might come back and do some more, but if I turn everything into one fraction, it's very possible I end up with some negative exponents and then have more crap to unravel later. So I don't want to do that until I know that I really should be factoring the denominator exponents in. Now, if they were fractional exponents in the denominator, I still would probably wait and just see what I have. Okay? So let's kind of see what happens here. So the 1/3 and 5/7 can go together. And then the 5 has nobody to go with, and the 3 has nobody to go with. But these x's can come together. And then I'm just, yeah, I'll leave it as a prime factorization, I guess. There's no harm in that. So to add 1/3 and 5/7, what do I need? Common denominator. What would that common denominator be? About a 21, right? So that'll turn into 7/21 plus 15/21. 7 and 15 is 22. If I go to the x, same situation. I have 1/3 plus 5/7. Everybody okay with what I did there? Now I notice the exponent of 2 in the numerator is bigger than 1, right? So I'm going to reduce this. Similarly, the exponent, the numerator is greater than 1, so I'm going to reduce from here. How am I going to do that reducing? Basically, I'm going to cancel 1, 2, and 1x. So I'm just basically subtracting 1 from the exponents. Let me write that in a different color so it's a little bit more clear if you go back and look at this, that it's a different step that I'm doing. Did you guys kind of get what I'm doing here? I'm trying to do this without having to do like a million steps and kind of doing this in a practical way. And then we can put all this stuff back into radicals, since it's now all the way reduced. And that would be a fine final answer. So here's a question for you guys. Back on this step, why did I just reduce a 1 out of the exponents here? Because seeing what I did, okay, that's fine, I guess. You could probably say, you look at it and you're like, all right, whatever. But the why of it is probably the hard part or the part that we need to make sure we understand, right? When it's time to do it later, that you understand why you're doing that, so you can do it again on your own. So subtracting the 1 out of the exponent is basically like reducing out like 1 factor of 2 from the numerator and 1 factor of 2 from the denominator, right? Because dividing by 2 to the first is the same thing as like subtracting 1 out of the exponent of a 2. Does that like if I have 2 to the third and I divide that by 2, that's like 2 to the 3 minus 1, or 2 squared, right? So why did I just divide 1, 2 out of the numerator and denominator? Well, there was more than 1 2 in the numerator, right? You had 22 out of 21 2's, and only 1 2 in the denominator. So hopefully that wasn't that hard to see. But if we look at the x's, I had more than 1 x in the numerator. I had 22 out of 21 x's. And I had 5 x's in the denominator. Why did I just subtract 1? Why not 22 out of 21? Well, if I did that, I'd have a fractional exponent in my denominator, right? Everybody's okay with that? If I did that and had a fractional exponent in my denominator, that was, oh, it's on the other sheet. That was one of the things that we said wasn't going to be a acceptable final answer, to have a fractional exponent in the denominator, because it was equivalent to having a radical in the denominator. So it would just mean more work for me to have to unravel that later. Why not just subtract 5 and get rid of all the x's in the denominator? Right? If I did that, then I'd have a negative x in my numerator, or negative exponent in my numerator, which again we said we didn't want to have an answer with negative exponents, so I'd have to untangle that mess later on. So to be clear, neither one of those things would have been wrong. You could have done either of those things. The problem is that they both would just create more work for us to deal with later. So you didn't really make anything simpler. You didn't get any closer to a stopping point for a final answer. You know what I mean? Maybe you don't. And if you don't, that's okay, because what I want to spend the rest of our time today doing is giving you a chance to work on the homeworks that I've posted, so that when this stuff comes up, you're able to kind of think about it on your own in context. And if you want to come up and talk to me about ask questions, or like, hey, this is what I did, like, is that the same way you would have done it? Like, I think I have the right answer. Is that answer okay? Is it fully simplified? Does it meet all the criteria? We can talk about all of those things on an individual basis, which is probably more closer to what you guys need right now than anything else. It's just a chance to kind of like work on some of the stuff where you can get some immediate feedback. Is that right? That feels pretty good? Okay. So I have 2 chapter 6 assignments here posted in. The first one should be fairly straightforward, where we're just reducing some radicals, multiplying some radicals, and then adding and subtracting some radicals. Okay with that idea? All of the situations on this page, we have like radicals, so that's not a big deal. Worksheet 2 has 2 pages. On the first page, we're just using converting back and forth between radical form and exponential form. And on the second page, we have some simplifying it, radical or exponential expressions going on. And some of these are quite challenging. So if you get to some of them and you're like, yo, this is a holy mess out of this thing, like, that might be right. That just might be the easiest, like, just might be what you have, because some of them are tough. Okay, so I'm going to warn you now, this last, whatever, 7 or 8 problems are probably more time consuming than the rest of the parts combined. Just as a fair warning. Again, you don't have to work through this in sequential order. In fact, I'd encourage you probably not to. Like, work on little bits from each of these sections to where you feel like, okay, I think I got the idea here. Skip on, like, find something else that looks kind of complicated. Try that one after you feel good, and if that goes okay, like, skip to the next most complicated thing. So skip around a little bit, so while you're here, you've had a chance to try the hard stuff, and get some feedback on it in case, obviously, there's a good chance you wouldn't finish 2 assignments in whatever time we have here. That way you've at least have like some example problems to look back at when you take the stuff home to work on your own. You know what I mean? Or you can ignore my advice and do it whatever way you want to. Like, I'm not going to really be looking, but if I were you, that's what I would do. Cool? Okay. Well, I'm going to shut up now so you guys can start on stuff. Again,